Welcome to this explainer. Man, I am absolutely thrilled to have you here today. If you're working in industrial automation, you already know the deal. Variable frequency drives, well, they're the beating heart of modern motor control. Today, we're taking a super structured, step-by-step look at programming the Delta VFD EL series. We're going to break down those core parameter settings, turning what can honestly feel like a pretty daunting task into a series of clear, logical building blocks.
Now, if you've ever cracked open a technical manual for one of these drives, you know they can be incredibly dense. We're going to save you from a 200-page slog through the documentation. What we're talking about is the Delta VFD EL, a really compact, sensorless vector control microdrive. But its true power, that lies in how it's programmed. We're going to demystify the exact sequence you need to get this hardware configured safely and efficiently.
Here is our blueprint for today. We're looking at navigating parameter groups, then user parameters in Group 0, basic parameters in Group 1, operation method in Group 2, input and output in Group 4, and finally, multi-step speeds in Group 5.
All right, Section 1, Navigating the Parameter Groups. Let's dive right into this and understand exactly how the VFD EL organizes its brain.
So the drive's parameters are smartly divided into 11 distinct groups by property. We've got Group 0 for user parameters, Group 1 basic parameters, Group 2 operation method, Group 3 output function, Group 4 input function, Group 5 multi-step speed, Group 6 protection, and Group 7 motor parameters, up to 11 groups in total. This modular setup means you don't have to memorize hundreds of random numbers, right? You just need to know which neighborhood to visit. Today, our focus is entirely on the crucial core groups for a startup: Group 0, 1, 2, 3, 4, and 5. For most applications, you can actually knock out all your settings right here at the start, no readjustments needed later.
Section 2, Setting up User Parameters. Think of Group 0 as the lobby of our drive. It's where we check in and establish our foundational operating rules.
The absolute most critical choice in this lobby is parameter 00.10. This is your control mode. You're basically choosing between two entirely different ways to drive your motor. If you set it to 0, you get standard voltage frequency, or V/F control. This changes the mains frequency and voltage without altering the motor's mechanical characteristic curve, which is perfect for your standard open or closed loop running. But if you set it to 1, you enable vector control. This mode actually modifies that mechanical characteristic curve, making it absolutely ideal for more advanced applications where you need really tight torque control.
But hey, before we leave the lobby, you've got to lock the front door. Parameters 00.08 and 00.09 are where you enter and verify a password. In an industrial environment, preventing unauthorized tampering is, well, it's just as important as getting the motor spinning in the first place. Once you've got that setup secured, you're ready to lay the physical groundwork.
Moving on to Section 3, Defining your basic parameters. This is Group 1, folks, and it's where we lay the physical foundation for the motor's operation.
Think of these settings as defining the literal physical limits of your machine. Parameter 01.00 is your maximum output frequency, and it's adjustable from 0.1 all the way up to a blistering 599 Hz. That is basically your ultimate machine speed limit. You'll also set your midpoint voltage and frequency here to shape your VF curve. And finally, parameters 01.09 and beyond, those govern your acceleration and deceleration times, ranging from 0.1 to 600 seconds. Think of these as your gas and brake pedals. If you set them too fast, you risk tripping the drive, but too slow, and your whole process lags.
So now that the engine is tuned, we hit Section 4, Choosing your operation method. This is Group 2, where we essentially define who or what actually gets to drive the car.
The really crucial point here is that you must explicitly tell the drive where to take its marching orders from. Parameter 02.00 controls the source of your frequency command, and 02.01 controls your operation command source. So, are you going to use the digital keypad right on the front of the drive? Are you wiring up external switches and relays to the control terminals? Or maybe you're integrating this drive into a larger network using the RS-485 communication port. Whatever it is, you have to make that choice right here in Group 2.
Now, what's really fascinating here is this specific number range, 2 to 12. This represents the PWM carrier frequency in kilohertz, which you'll find at parameter 02.03. This is a brilliant little setting. By adjusting this carrier frequency between 2 and 12 kilohertz, you can actually fine-tune the acoustic noise of the motor against the electrical performance of the drive. A higher frequency means a much quieter motor, but it can increase heat and leakage current in the drive itself. It's just a fantastic balancing act for the informed engineer.
And that builds
right into Section 5, Configuring Input and Output. This covers groups 3 and 4, where we map out the drive's nervous system.
When you wire your drive and pop off that control board terminal cover, you're going to immediately notice the green terminal blocks. These are your multifunction input terminals, labeled MI1 through MI6. These physical connection points are exactly how the outside world triggers all those internal parameters we've been setting up.
Through parameters 04.04 and beyond, you assign specific functions to those MI terminals. The manual shows some really clear wiring diagrams for both 2-wire and 3-wire control setups. For instance, in a standard 2-wire setup, you might program MI1 so that when the circuit is closed, the motor runs forward, and when it opens, the motor stops. MI2 could then handle the reverse command. You are quite literally bridging the physical switches on your factory floor directly into the digital logic inside the drive's brain.
Finally, we reach Section 6, Mastering Multi-Step Speeds. Welcome to Group 5, where we teach the drive to perform some really complex automated dances.
This right here brilliantly illustrates the power of our building block approach. Because we've already set up our operation methods in Group 2 and our input terminals in Group 4, we can now use them to trigger multi-step speeds here in Group 5. By programming parameters 05.00 through 05.14, you can set up to 15 distinct frequencies. You then just assign your MI terminals to toggle those speed commands. Depending on which combination of terminals is active, the drive instantly shifts to the exact pre-programmed frequency. And the best part, it does all of this without needing some expensive external PLC micromanaging the speed profile.
We've navigated the groups, we've locked down our user parameters, set those physical limits, chosen our operation method, mapped out the inputs and outputs, and unlocked 15 automated speed steps. The building blocks are fully in your hands now. So with that incredible level of precise, programmable control at your fingertips, what complex automated sequence are you going to build next? Thank you so much for joining me in this explainer. Now go get those